everyone. I hope you're all doing well. In our last video, we have discussed properties of different states of matter and how those different states can convert into each other. In this video, we will discuss few other points of that same topic, states of matter, like heating, cooling curve, pressure, and temperature will affect on the volume of gas, and also we'll discuss diffusion. Now, in this part, heating and cooling curve, this is showing that this is the on x-axis, this is the duration of providing heat to the substance, and on y-axis we have temperature. So when we will start heating to the solid, it will absorb energy, and that heat energy will raise the temperature of it, and as you can see that the temperature is rising. And if the temperature is rising, definitely the kinetic energy of particle is increasing, and these will definitely, these are trying to move apart. As their kinetic energy will increase, particles will move faster, these will vibrate faster, and at one point their vibration and their energy will be so high that these will move apart and convert into liquid state. So at that point, initially, as you're rising the temperature by providing heat, but at one point the temperature remained constant. There was no change in the temperature. As you can see that at this point the temperature remained constant for this duration. Why the temperature remained constant? Because at this point the heat you are providing is not utilized to increase the temperature, but instead it is used to move particles apart, to break the forces of attraction present between these particles. So at this point, still you are providing heat, you are heating your solid, but that heat is used for breaking the forces of attraction between particles. And at this point, when the forces are broken and these particles are moving away, so the state of that solid will convert into, definitely it will change into liquid. So this is the point where melting will occur and solid will convert into liquid. And again, if you will continuously provide that the more heat to this liquid, initially the temperature of the liquid will rise, but at one point where the temperature will rise and kinetic energy of particle will increase so much that these molecules will move apart further to convert into gas. So at this point, the temperature, the heat which you are providing is utilized to break the force of attraction between these liquid particles, and these particles will move so far away that now these are converted into gaseous state. So then again, if you will heat that gas further, its temperature will rise. And similarly, cooling curve, where you have a gas, its energy is already variable. You know that the in our last video we have studied that the energy, that was kinetic energy of gaseous molecules, is highest. So if you want to convert gas into liquid, you have to cool the gas, so the kinetic energy will release in the form of heat energy. So after the loss of energy, the molecules will become comparatively slower, and this slower speed will allow these particles to make forces of attraction between them. So gases will convert into liquid, and on further cooling, the energy of liquid molecules will low, and that will allow them to make more further stronger forces of attraction, and the liquid will convert into solid state. So this is a cooling curve where gas was, if you lower the temperature, you're lowering the temperature, and the gas is converting into liquid. At this point the temperature was constant. It means that this is the point where gaseous particles are making forces of attraction with each other, and now these are converting into liquid state. So this is the point where condensation will occur, and on further cooling, the liquid, that is, now this is the liquid state. Now at this point, liquid will its temperature will become further low, and then at this point the forces of attraction are making, and at this point there is no heat loss. The heat which should be lost during this point, that is used to make the forces of attraction, and then further cooling, the change will occur in temperature. So these are the points, these horizontal part of these curves are those where the conversion of state will occur and the forces of traction will form or break in these heating and cooling curve. And as you can see that these temperatures, these horizontal lines are showing that there is a one very fixed point where at which, or a very fixed temperature at which the melting is occurring, and a very fixed temperature that is the boiling point of that liquid. It shows that the substance for which we have drawn this curve is a pure substance, because pure substance can have fixed melting in boiling point or freezing point or condensation point, all of this. So pure substance will have fixed melting and boiling point. Let's suppose water, if water is pure, its melting point is 0 degree centigrade and its boiling point would be 100 degree centigrade. But if you will have an impure water, then the boiling point will be more than 100 degree centigrade and the melting point will be less than 0 degree centigrade. So this is how if an impurity is present in your sample, that will change its boiling and melting point. Now that substance will boil at range of temperature, like it can boil at 100 degrees centigrade, 101 or 102. So the boiling point will be more than the required temperature. So these were heating and cooling curve. Now what is the effect of pressure on volume of gas? So we know that gases can have large spaces between them, as you can see. So if you will apply pressure on a gas, as there are larger spaces, so by applying pressure, molecules can move closer to each other. So the spaces between them can allow these particles to move closer. So that is why volume of gas can decrease by increasing pressure. As you were applying 1 atmospheric pressure, so the volume was, let's suppose this one, which is maybe 10 centimeter cube. So if you will apply further more pressure, then the volume will decrease, because gases are compressible. And if you will increase or decrease temperature of a gas, what would be its effect on the volume? That could be like if you will have a constant pressure, 1 atm in both of these container, we are applying the same in a constant pressure. But in this container the gas was at 20 degrees centigrade, but by increasing temperature, now molecules will gain energy, that heat will convert. If you will further heat this container up to 40 degrees centigrade, its temperature will increase, and that heat which you are providing is converted into kinetic energy, and that kinetic energy will allow these particles to collide with each other, with the wall of this container, and these particles will move away, and during this whole process, these will apply pressure on the wall of this container, and this wall will move upward, so the gas will expand. So by increasing temperature, the gas will expand, and by increasing pressure, the gas will compress. Right? There are basically laws on these two properties of gases. One of them is Boyle's law, and then Charles' law. For temperature, Charles' law, and for pressure, Boyle's law. But we are not going to discuss it in depth. All right, diffusion. It is the most important part of this topic, and you will see that number of times examiner has asked questions from this part. Now diffusion. What is diffusion? According to kinetic particle theory, as we have learned in our last lesson, that kinetic particle theory tells us that every particle in any state is always in motion, right? This is kinetic particle theory, and according to this concept, we have to use this concept to define diffusion. So diffusion is the movement of particles from higher concentration to lower concentration. If you will apply perfume, that will spread into the complete the room where you are. So why it is spreading? Because the part of body where you have applied the perfume, there was the higher concentration of particles, and these particles will move away toward that area where their concentration is less, up till until then the concentration, the number of particles in the whole room are now become equal. So diffusion will remain continuous. So what is diffusion? The random movement of particles from an area of higher concentration to area of lower concentration, right? So factors affect it. Is possible in liquid state, gaseous state, or it is very slow in solid state, or we can say that diffusion is not possible in solid state at this point. So let's suppose if you will have a liquid, right, and if like that liquid is, let's suppose, water, which is colorless, and if you will add a drop of red ink into this glass of water, then what will happen? That the red ink, after some time, the red ink will move, spread into this whole container, whole glass of water. So why it is happened? Because the particles of red ink, the liquid, can move from higher concentration to lower concentration. We know that particles can move according to kinetic particle theory. Every particle is always in constant motion. So that is why this is the proof. Diffusion is the proof of kinetic particle theory, that if something is moving away and it is moving into the whole container by itself, it's mean that the theory that was kinetic particle theory, according to that particles are always in constant motion, is correct. So this diffusion is actually the proof of the kinetic particle theory. Now factors affect on the rate of diffusion. Rate of diffusion means rate is anything like the change with respect to time. On a simplified way, we can say that it is speed of diffusion. So speed of diffusion, which one will diffuse faster, which one will move from higher concentration to lower concentration in a lesser period of time. So temperature and relative molecular mass, these are two factors which will affect on the speed of diffusion or rate of diffusion. So one of them is temperature, right? Let's suppose if I will add a drop of red ink into this container and drop of red ink this with the same amount into this container, right? So which one, in which container this red colored ink will diffuse faster? It will diffuse faster in 40 degrees centigrade. This container which has 40 degrees centigrade, container B, let's suppose. Why? Because we have just learned that at high temperature the kinetic energy of particle will increase and these will move faster. So you can explain it in this way. So at high temperature the diffusion will become faster. Like if you will apply perfume on that body part where the temperature is high, that perfume will diffuse faster. So this is how the temperature will affect on the rate of diffusion. I mean, it is directly proportional. So temperature directly proportional means that if something will increase, the other factor will also increase. So temperature and diffusion will have this relation. If you will increase temperature, the rate of diffusion or the speed of diffusion will increase. Second factor is relative molecular mass. The heavier the mass of a molecule is, the slower that molecule will diffuse, right? So it's mean that the lighter will diffuse faster. Okay, so the lighter one will diffuse faster. So how we can find that which one is lighter, like helium, neon, hydrogen and carbon dioxide. There are these four substances. Now how we can know that which one is lighter? We will go to our periodic table. Helium, it has 4 atomic mass, right? Relative molecular mass or atomic mass. Helium, because it is made up of only one atom, so we will say that its mass is 4. Neon has 20 atomic mass, right? So that is why its mass is 20. Then hydrogen, where it is, so this one is hydrogen, this one is atomic mass, this one is atomic number, we will not use this one, this is the atomic mass. So hydrogen has atomic mass 1, but in hydrogen molecule there are 2 atoms, so you will multiply it with 2 to get the mass of hydrogen, right? So this is the mass of H2 molecule. Carbon dioxide, carbon has atomic mass 12. So how many carbon are present in this formula? Only 1 carbon, right? If there is no number under this symbol of an element, it means that that atom is 1. So carbon, there is only 1 carbon, so 12 into 1. Plus, if you are having different atoms, then you will add their atomic masses. So carbon, this is the mass of carbon. Then the mass of oxygen. What is the mass of oxygen? This is oxygen, 16. So multiply 16 with 2, because there are 2 oxygen in carbon dioxide, so you will multiply it with 2. So 16 into 2 and 12 into 1. So you will get, by adding these two, the atomic masses of different atoms, you will get 44. So this is the heaviest one. So what do you think, that which one will diffuse faster? So this is the fastest one, right? Because its atomic masses or its molecular mass is 2. So this is how you can understand that which one will diffuse faster. So they will give you some questions and you just have to understand that, okay, which one is having lower molecular mass, that will move faster. So this is a very common example for diffusion in our books. So let's suppose this is a cotton wool soaked in concentrated hydrochloric acid, and this one in ammonia. The formula of hydrochloric acid is HCl and the formula of ammonia is NH3, right? When these are their fumes, when their fumes or their gases will combine, these will combine together, these will make another compound, that is ammonium chloride. When HCl and ammonia will join, this will make ammonium chloride, and it will appear as in the form of white fume. So ammonia, this one is ammonia and this one is HCl. At any point of this tube, ammonia and HCl will join and you will get a white colored fume. That could be A point or B point or C point. Now they will ask you that at which point A, B or C both of these molecules will join. Now how we can answer it, that HCl, will find that which one is lighter. That one, if ammonia is lighter or HCl is lighter, it will move faster. So first of all, we will find their molecular mass. So hydrogen, there is only one hydrogen, so, and the mass of hydrogen is 1, and the mass of chlorine, here it is chlorine, this is chlorine, 35.5, right? So you will use the periodic table to write their atomic masses, 35.5. So 1 is for hydrogen, 35.5 is for chlorine, because these two are different atoms, so you will add their atomic mass, and this is how you will be able to get their molecular mass. So this is the molecular mass of HCl, right? And ammonia, how we can find its mass? Nitrogen has 14 atomic mass. There is only one nitrogen, so you will multiply 14 with 1. I'm not writing it simply because it is 1, so that is why you can simply write 14. Hydrogen, the mass of hydrogen is 1, but there are 3 hydrogens, so multiply 3. If there are same number of atoms, more than one same atom, you will multiply it with their number with their atomic mass. So this is the mass of nitrogen, this is the mass of hydrogen. Just add these two masses and you will get 17, which is the mass of ammonia, right? This complete molecule. 36.5 is the mass of HCl. So which one is lighter? Which one is lighter and which one will diffuse faster? Right, definitely ammonia. It has 17 atomic mass, it will diffuse faster. So ammonia will diffuse faster and it will reach in no time at this point, and HCl will just reach at this point because it is heavier. So we will just write the chance or probability of finding that point where these two will join. So this will make sense that ammonia will move faster and HCl will move slower, and at point A these will join and you will get a white fume at this point A. So this is how they can ask you questions related to diffusion. Now in our next video we will discuss past paper questions from O levels and IGCSE related to this topic of states of matter. Thank you so much.